ShabbatSmart hot water controller system explained. So here we have a hot water cylinder, cold water inlet here at the bottom, hot water outlet, relief valve, and a coil for the boiler to heat up the cylinder. So there's a coil inside the tank, inlet and outlet from that coil. We have a programmer which calls for the system to operate. When it calls for the system to operate, it opens a zone valve. The zone valve, when it's fully open, calls for the boiler to operate. And that's a standard weekday operation. For Shabbat operation, for preparing the cylinder for Shabbat and for operating it over Shabbat, we add a mixing pump, a special hot water designed mixing pump, not a heating pump, and a relief valve. Now we're going to show the system. So we add a pipe going off the hot water outlet back into the cold water inlet. This pipe passes by a non-return valve to ensure cold water does not bypass into the hot water, and a pump to allow mixing the water in the tank when the controller needs to mix it. In addition of this bypass, we take a pipe that goes down in through a gate valve to allow balancing the flow into a zone valve, which will allow us relieving water to the drain when the controller requires doing so when preparing the tank for Shabbat. We add two sensors on this tank. We add a pipe sensor. Here we have a sensor on the copper pipe coming off the tank on the hot water outlet. You see the sensors touching the copper pipe. This first piece must be copper. This is then covered with aluminum tape, which helps spread the heat, and then insulation over it to ensure it keeps the temperature. This sensor detects any change of heat rapidly. It's a special sensor. We add another sensor on a standard tank at the top of a tank. So here we make a cut in the insulation, expose the stainless steel at the top of the tank. Again, install the tip of the sensor at the top of the tank, touching the metal, aluminum tape over it. We either place a piece of insulation back, or we spray foam back over here to seal it up. In the case of a megaflow cylinder, as a megaflow has a baffle at the top, an expansion baffle, the water level is the same level as the relief valve. So anywhere on that level, you take a circular saw with a center bit, you start a hole. When you cut through the external sheet metal, which is quite thin, you then reach the insulation, you remove the center bit and finish the cut to expose the tank. Once it's exposed, if it's not already clean, you just quickly clean it. You place a sensor touching the tank, again, the same level as the relief valve. You put aluminum tape over it and insulation or insulation foam back over it to ensure it's completely sealed. If it's the insulation back, you just seal over it. This way we have, as we said, two sensors, one pipe sensor, tank sensor, and a regular one at the top, and a megaflow at this level. So now we have the tank, we have a boiler valve, and that's a specific one. We use a zone valve to allow the water from the boiler. It needs to be this specific one, as it's a ball valve that closes hermetically, compared to other ones which has a rubber that moves up and down, which do not close hermetically. And the relief valve, the same valve, and the circulation pump, which should be a hot water circulation pump, not a heating circulation pump. Now let's look at the wiring. During standard operation, on a weekday, you have a weekday controller, which basically receives live and neutral to power itself, and the switched live that goes on to open the zone valve. That goes out to open the zone valve. When on the way to the zone valve, it passes by a cylinder stat just to ensure that it stops the water heating at the temperature set on the cylinder stat. and there's a protection, and from the cylinder start it will open the valve. When the valve fully opens, it has a micro switch inside, which in turn will switch on the boiler. Hot water will come down through the flow. As this is open, it will go into the coil of copper inside the cylinder, come out of the coil back to the tank. That's weekday operation. Now let's have a look at the ShabbatSmart controller. So on ShabbatSmart controller, we have the screen with some components on the board, and then the relays which operate the different items that ShabbatSmart controller should be operating. So let's have a look at all this wiring and how it's done. So we will start from the very top on the sensors. As we saw, we have a tank sensor, we have a pipe sensor, and we have an option for a third sensor in the case where you have multiple tanks. Then we disable the weekday tanks, leave only the Shabbat tank to operate, but we place another sensor to ensure that no weekday water is coming through. If it is coming through, the controller will read it and immediately stop all the heating operation and present a warning on the screen. Here we have a Shabbat weekday switch. You can have it manual or you can have it by Wi-Fi. A manual is just a switch, which here we have one on the box. You can extend the cable from here to the kitchen or anywhere else to switch on and off, or you can use our Wi-Fi controller that we supply, and then you can trigger it on time relation to sunset. So for example, Friday 40 minutes before sunset to go into Shabbat mode, and Shabbat 72 minutes after sunset to go into weekday mode. Power supply to power the box is separate to the power supply for the relays. So power supply to supply the box itself comes in a 9 volt over here. We can see the cable, here it is. We have a 9 volt power supply which we supply with the box. And this supplies the components on the controller itself. It's also bridged to this connector. And here we used, as you can see, the negative for the kitchen LED, 9 volt LED that goes in the kitchen to allow us to know when Shabbat mode is triggered and the water is in Shabbat temperature. The live, the plus, which goes out, goes under the board, that's factory installed, and goes into the relay and out for the kitchen LED. Obviously, this is extended into the kitchen with a cable. There's another power supply, and that's a high voltage, and every country will be different voltage. And that goes up, as we can see, into the board. And the live goes through a fuse and out to different components. The neutral has a bridge on the PCB, and that goes to the neutral terminal block. Now, let's have a look at the components. So we have 6 relays. Each relay has a common in the center, and then a normally closed and a normally open. Normally closed means that when the relay is not energized and the LED is off, there's a connection between the common and the right connection, which is normally closed. That connection is made. When the relay is energized and the light is on, like we have in this, then the connection is between the common and the normally open. So the right is normally closed, the left is normally open. When the relay will be on, there will be a connection between the common incoming to the normally open side. Now we can look at all the different relays. We'll start with a relief valve. Relief valve has live coming in the center, as we can see over here. The live goes out and goes into all the relays. The fuse protects the board, and it goes into the relief valve, so it comes in the common, and then it goes out on the normally open to the cable for the relief valve. The negative comes from the negative board, and this goes all the way down to the relief valve. So we can see the cable. Same applies to the mixing pump. Live comes into the center, it goes out into the cable, and you can see this cable over here going to the mixing pump. Heat demand. So Shabbat heat demand, we can see over here, again, the live comes into the common, goes out from the normally open when we switch on the relay, and that will go down together with the neutral to the zone valve. It will again pass through the thermostat, and Shabbat mode, as the thermostat is set to temperature much higher, will just be a protection as the temperature is controlled by the Shabbat controller, not by this. It will be only a limit. And when it's fully open, it will start the boiler. Now, Shabbat mode switch. During the weekday, this relay is off. When the relay is off, as we said, the common and the normally closed are connected. So as we can see during the weekday, we can look at the programmer. It receives live and neutral permanent. Here's the live permanent. Here's the neutral permanent. And it has a switch live. When it calls for heat, then power will come down the switched live and we'll go into the common connection of the Shabbat mode contactor. Then, as the relay is off during the weekday, it will continue on through the normally closed connection and down to the valve to open the valve and start the boiler. However, once in Shabbat mode, this illuminates, the relay energizes, and it disconnects the normally closed connection, and now the valve is only controlled by the Shabbat relay. So this is to make sure we cut off the weekday heating. We have another relay for boost mode, which if we have booster system, which we need to disable for Shabbat, then we will power it into the common and then out to the booster, and on Shabbat mode, this relay will go off and therefore cut off the booster. Last one is the kitchen LED. As we looked at that, we use a 9 volt for it. Now, each one of the relays is completely independent, which means you can put in any power you want in order to get out, any voltage. You can do different voltages and different relays and control. So if you have a 24 volt valve, for example, you can put, instead of the bridge over here, you can put the separate 24 volt in and out for your valve. So we looked at all the connections at the bottom. We understand all the basic wiring of the system. It's very simple and straightforward. We looked at the top. We know the tank sensor, pipe sensor, and another sensor for branch if we have multiple systems. Let's look at one more item, and that's the switches on the board. So we have on the board 3 rotary switches, which are pre-calibrated. However, this top one is the mixing time on each cycle, which is between 120 and 240 seconds. By default, it's 240 seconds. The relief time between 60 and 240 seconds. By default, it's 120 seconds. And pasteurization temperature. Pasteurization is a mode that we can enable using these dip switches. We can enable pasteurization. We'll show in a minute. And here we set the temperature between 50 and 70 degrees. The default is 60 degrees. That's how it's sent out. Pasteurization is mainly used when you have multiple cylinders and you have a dedicated cylinder for Shabbat. And after Shabbat, you want to pasteurize the cylinder. So at least once a week it's pasteurized. If the water temperature is during the week on a single tank high anyway, so there's no need to pasteurize it after Shabbat. Now, let's have a look at those dip switches. So those dip switches will allow us to set a number of things. So the first one is dip switches 1 and 2. They are set to configure the Yad Soledes boy temperature. It could be the default as of Shlomo Zalman or Yerbach when they're both off, which is 45 degrees. You can also do 43 degrees or 40 degrees. Important to remember that after you make a change, you have to reset the power to change for the change to take effect. Dip switch number 3 will dictate pasteurization on or off. By default, it's off. Number 3 is off. If you switch it on after you finish Shabbat mode, go into weekday mode, it will do pasteurization cycle. Dip switch number 4 is Fahrenheit or Celsius. By default, it's off. That will be Celsius. So this is the ShabbatSmart hot water system heated by a boiler. During Shabbat, the system will continue heating the water to a temperature below Yad Soledes Boy, however, in a way that the user who uses the water does not cause any action to happen on Shabbat. He doesn't cause anything to start or anything to stop. If you want to see more information about it, have a look at Shmirat Shabbat Kehilchata, Perek Aleph Ilchot Bishul, the last edition, Ha'ara Kuf Lamed Hei. This is a brief description of the installation. Please follow the installation diagram for full exact details.